Hey pre-calc, let's take a look at the law of cosines. Again, the law of cosines and sines is so powerful because we could use it on any triangle, not just right triangles. So the first thing we're going to do here is label this triangle. Let's call it angle ABC. And then the sides across from angle A would be side little a, here's side little b, and across from C is side little c. Okay, so here's how the law of cosines works. It kind of reminds me of the Pythagorean theorem. So we start with c squared. C squared is equal to a squared plus b squared. And that would be if it was a right triangle, okay? But this is not, so we have to take something off. We have to subtract 2, and then one of each of these sides right here. So 2 times a times b times the cosine of angle big C. All right, and so this side right here that you started with should match with the angle that you finish with. Now there's 3 different versions of this, of course, right? What if we started with a squared? Then it would be b squared plus c squared, the other 2 sides, but then we have to subtract minus 2, one of each of these, the b times the c, and then it's times the cosine of angle A. And how you start is how you finish. And then the third version, of course, b squared equals the other 2 sides, a squared plus c squared, minus 2 times side A, side C, times the cosine of angle B. All right, now I don't want you to think that you have to go home and memorize all 3 of these long, nasty formulas. If we figure out how things are related, okay, it'll make a lot more sense. So let's take a look at this first one right here. If we have side C to start with, then it's the other 2 sides minus 2ab times the cosine of angle C. Okay, so how do we know which one to use? We're using all 3 sides. It's the angle that will determine this. Okay, the angle will determine the setup. So we really have to figure out what angle we have because that's how you start the law of cosines. All right, let's do a couple examples together. Okay, we have to solve this triangle. So the first thing I'm going to do is draw a diagram of the triangle, list the information we have, make a list of the information we have to find. Okay, so let's just draw a triangle A, B, C. I always draw it like this. It doesn't matter. Information we have, side little a is 11. Little b is 5. Angle C is 20 degrees. Okay, so the 3 pieces that are missing, we have 2 angles here. We've got measure of angle A, we've got measure of angle B, and then the only side that we're missing is side little c. So if I find these 3, I'll have the triangle solved. Okay, so how are we going to start this setup? I'm going to start by looking at the only angle we know. And if you will go across that triangle, side little c is where it's at. So we're going to start with side c squared. And then you've got the other 2 sides. So it's 11 squared plus 5 squared. And then remember that was too much, so minus 2, and then times each of those sides, and then it's the cosine of 20 degrees. Okay, when you have this kind of setup, it's really going to be all calculator work. Okay, so we're going to type this in. This is all calculator. The only thing I would need to see would be this setup right here, okay, except this is c squared. Okay, so then we're going to have to square root our answer. So let's show you how to do that in the calculator. Okay, so first of all, let's get this entire thing right here typed in. Make sure that you're in degree mode. We've got 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. Okay. But that is c squared. So how are we going to figure out just c? We would have to square root both sides. So I'm going to square root, okay, and you have to make sure that you get the entire answer. Don't just type in this many decimals. There's more decimals behind the scenes that you don't have. There's two ways to do that. Okay, you can hit second answer, which is in blue, okay, or you could just go up here and grab that, okay, and there's more decimals than that. It's going to square root the answer, and c is approximately equal to 6.53, rounded nicely. So if I look back at the triangle, I'm going to label this as 6.53. Okay, now we have to find one of these angles. It doesn't matter which one we go for. Let's just go for angle A. All right, so I'm going to go for angle A. That means I'm going to have to start with 11 with that side. Remember, how you start the law of cosines kind of matches with how you end it. So since we're using angle A, I have to start with side 11 squared equals 6.53. That side squared, there's really no getting around it. I'm going to have to use that rounded decimal. Plus the other side squared minus 2 times 6.53 times 5 times the cosine of angle A. Okay, let's see what we're going to do here. To get to angle A, I'm going to have to solve this. I'm going to have to subtract this and subtract that. Okay, so let's start with 11 squared. Where can you see 11 squared? Subtract 6.53 squared, and then subtract 5 squared. Okay, let's see. So far we have 53.3591. I'm going to keep this right here on my calculator. I'm just going to write this down to help me think. Equals negative 2 times 6.53 times 5 times the cosine of A. The next step would be to divide both sides, okay, by all this stuff because we're trying to get to A. So we're going to divide by all these numbers on both sides. 6.53 times 5. That all cancels out. Okay, so I'm going to take my calculator. I'm going to take this answer. So go up there and get it. So you get all the decimals you can. And we're going to divide by, and then we're going to use parentheses. You have to make sure you divide by all of those things. So negative 2. You could open up more parentheses or just use the multiply sign. Okay, all of this is in the denominator. Negative 2, 6.53, and then times 5, and then close parentheses. It is super important that all these things are in the denominator. Okay? We could also use alpha y equals and do a fraction. Okay? That would be another way to go. So if you did alpha y equals and you got the fraction command, okay, you'd have to go up here and get that answer for the numerator. And then in the denominator, we would have had negative 2 times 6.53 times 5. So visually, this makes a lot more sense. Everything is clearly getting in the denominator. Okay, and so that might be another way to go. All right, so now what we have all these decimals, negative 0.8, blah, 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 equals cosine of angle A. How are you going to find the measure of angle A? We'll have to do cosine inverse of that answer. So let's do second cosine. Cosine inverse, go up there and grab that. Go up there and grab that answer. Cosine inverse of that decimal right there. And the measure of angle A, rounded to 2 places, is approximately 144.80 degrees. If you look at this triangle, measure of angle A, we now know is 144.80. Okay, when you're down to two angles, you can simply subtract to find that third angle. So let's do 180 minus 144.8 minus, what's the other angle? 20. Okay, I'm going to type what I wrote here so that the three angles on my paper they add to 180 degrees. So 15.20 degrees would make all of these angles add exactly to 180. Okay, Law of Cosines has some trickier calculator work. Okay, next example, we have a bunch of sides here. So we've got triangle ABC, and let's go ahead and write down the values. So side little a is 9, side B is 7, and side C is 5. Okay, so for this example, we need to solve the triangle, and it would be all three angles we're finding. Measure of angle A, measure of angle B, and measure of angle C. Okay, I really need you to be following along with your calculator. Are you typing these things in with me? Okay, good. I hope so, because this is tricky stuff. Any problems, make sure you ask in class tomorrow. So we're going to go for an angle. Let's just go for angle A first. Okay, if this is the angle we're going for, we're going to start with side 9. 9 squared equals 5 squared plus 7 squared, one of each. And then minus 2 times the 5 times the 7. And of course, this is the law of cosines. And so where did this all start? With angle A, angle A. Okay, this is all I really need to see on the paper. Everything from here on out is calculator. Okay, so this is the setup that I need to see. Now, how do you work the calculator? Okay, so step 1, you'd have to subtract these values. Okay, so step 1 is subtract those values. Step 2 would be to divide both sides by those values. Okay, and then step 3 would be cosine inverse to find the measure of the angle. Let's see if we can do everything with just calculator work. Okay, clear this out. So we've got 9 squared. We're going to subtract 5 squared and subtract 7 squared. Okay, so we're going to subtract those two sides from the right side. Oh my. Okay, now maybe what I'll do is use alpha y equals. I'll get the fraction command. Okay, so now we're going to go grab 7, and we're going to divide by negative 2 times 5 times 7. Okay, so now we've divided this away, and then we have to do cosine inverse of that answer. Cosine inverse of that answer, and angle A is what? Angle A is 95.74 degrees. All right, let's try the next one. Let's set up to find angle B. Angle B. So if we're going for angle B, we would start with the 7. 7 squared equals 5 squared plus 9 squared. And then minus 2, okay, times 5 times 9, one of each of them. And then cosine of angle, this is angle B. Okay, to get to angle B, you'd want to subtract these two, and then divide by this, and then cosine inverse that. So let's see what we got here with our calculator. 7 squared. Let's subtract 5 squared, and let's subtract 9 squared. Then I'm going to do alpha y equals. We've got, let's go grab that left side. Then we have to divide by negative 2 times 5 times 9. Okay, so we've divided all that away, And then we're going to cosine inverse. You could do second answer, or you could go up there and grab it. And angle B is how much? Rounded to two places nicely. I hope you got 50.70 degrees. So once you have two angles of a triangle, okay, you don't have to do another law of cosines. You can just subtract from 180. I'm going to use these decimals right here because I want to make sure all three angles for my answer box add up to 180 exactly. So 180 minus 95.74 minus 50.7, and angle C is how many degrees? It's going to be 33.56 degrees. Make sure you put units on that. Okay, let's keep going here. We got a couple of word problems, right? So we've got two trains leaving a station on different tracks. So let's just kind of put the train station right here. Here's the station. Okay, and we've got two different tracks. So here's some train tracks going this way, and then here's some train tracks going that way. Okay, and they make a 137 degree angle at the station. Okay, there's the vertex. The first train travels 1.7 miles away. Okay, so it goes 1.7 miles. And the second train travels 2.5 miles away. Okay, how far apart are the trains from each other? Okay, so that's this side right here. Okay, how far apart are they? I'm going to call that X. Call that X. Let's see, can we do the law of sines? I do sine of angle 137, divide by that. That's an unknown variable. Then I would have to do another angle, which I don't know. So step one, can we do law of sines? If not, we'll have to do law of cosines. Okay, and we have 137, so that means we're going to start with side x. X squared equals the two sides, 2.5 squared plus 1.7 squared. That's like Pythagorean theorem, but then we have to subtract 2 times each of the sides times cosine, and the angle is 137 degrees. Okay. Once you write down this law of cosine setup, it's really all going to be calculator work. Okay, all of this can be typed in the calculator. You're going to get x squared equals this huge answer. Then you're going to have to square root both sides and get x approximately equal to. So let's see. 2.5 squared. Play along with me, please. Plus 1.7 squared minus 2 times 2.5 times 1.7 times the cosine of 137. Okay, so that's those decimals there, but we're going to have to square root both sides. Square root, and x is approximately what? Rounded to two places. Don't forget to type some units. 3.09 miles. The trains are 3.9 miles away from each other. Okay, the last one we have here is a parallelogram. Okay, maybe something you remember about parallelograms is opposite sides are congruent. So if that's 7 meters, so is the top. Opposite sides are congruent and parallel. Opposite angles are also congruent. So if that's 50, okay, this one's 50. What about consecutive angles? What's the measure of that angle right there? Consecutive angles are supplementary, so this obtuse angle would be 130 degrees. Okay, good job remembering some of your geometry. So to find the length of the two diagonals, I think what I'm going to do is draw this parallelogram 2 times. Okay, so first, let's draw the parallelogram like this. Okay, And let's draw in, okay, this diagonal right here. So that's the short diagonal. We've got 5, 7, we've got 50 degrees, and they want us to find diagonal 1. I think that's going to be nice with some law of cosines. Let's draw the parallelogram again, just because it gets kind of complicated if you crisscross all these diagonals. This time I'm going to draw in the long diagonal. I'm going to call this diagonal number 2. The angle up here is 130, and the sides are 5 and 7. We'd have another law of cosines. Okay, I don't know if you guys remember geometry. Do these diagonals right here, does that split that angle in half? No, because the parallelogram is tilted. This is not half and half. Okay, so we can't really work with this. We're going to use the 130. Okay, let's go for diagonal 1. Using law of cosines, diagonal 1 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 50 degrees. This is just straight up calculator work, okay? Don't forget, okay, square root both sides, and make sure you use your answer command. So what is the length of diagonal 1? 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 50. Don't forget to square root your answer. And we're getting 5.39. 5.39 meters. Okay. That looks like the short diagonal. That's the short one. Okay, let's do the other diagonal. Okay, we're going to go for D2. Diagonal 2 squared. Okay, so we've got similar setup here. 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of, this time it's 130 degrees. This would just be straight up calculator work. Diagonal 2 is approximately how much? And the diagonal is 10.91 meters. That makes more sense for the long diagonal. Remember, bigger angle is going to be across from a bigger side. Okay? I can use the law of cosines to solve triangles and apply it to word problems. I hope so.